Let's consider problem solving involving momentum and impulse. So, you receive a package from Amazon. Packing is made of bubble wrap to protect the contents. In transport, the package is dropped. So then we know some specific numbers about the package. We have a mass of 920 grams. When it's dropped and it reaches the ground, it's traveling at 2.1 meters per second, and that would be downward. The object stops, the package and the bubble wrap compress, which results in the object taking 0.23 seconds to fully stop. So we've got two pieces of information there, 0.23 seconds and stop. So that means the 2.1 meters per second is the initial velocity, and the final velocity would be 0 meters per second because it stops. In part A, we want to calculate the momentum of the package as it reaches the ground from falling. So before it actually hits the ground, right as it reaches the ground. So on part A, momentum, your equation, m times v. So the mass in kilograms, converting the 920 grams over, that'll be 0.920 kilograms, multiplied by negative for downward, 2.1 meters per second. That's going to give us a momentum value of negative 1.93 kilogram meters per second, and the negative we'll interpret as a direction to be downward. Part B. Calculate the average force applied to the object as it is stopped by the ground. So your package is dropped, it hits the ground, and it stops, and that ground is going to apply an upward force to be able to stop it. Well, that stopping is a change in momentum, and a change in momentum is impulse. So our impulse equation, J, is equal to F delta T, which is equal to M delta V, which is equal to change in momentum and the area of a graph if we have a force versus time graph. So we have a lot in that equation. We're going to identify the pieces that go along with what we know. Well, we want to calculate the average force, so we have to use this piece. And we know a lot about the momentum, so we're going to use this specific segment of that whole equation. So then F is our unknown. The time period that it takes to stop is 0.23 seconds. The mass of the package, 0.92 kilograms. Change in velocity, that would be final minus initial. The final is 0 minus the initial, was a negative 2.1 meters per second. And then solve your equation down. So that's going to give us a force of positive 8.4 newtons, and the positive we would interpret as the upward direction. Part C. If the object had been in an ordinary envelope, it would have taken 0.18 seconds in order to stop. Calculate the average force. So then part C, we're redoing a similar calculation to what we did in part B, except now we're saying, okay, it's an envelope now, and our time period is a little bit shorter, 0.18 seconds. So we're still going to use the same equation and even the same segment of the equation. F delta T is equal to M delta V. F is our unknown. Our time period is now 0.18 seconds. The mass is, we're going to assume the same, 0.92 kilograms. And change in velocity, also the same, 0 minus a negative 2.1 meters per second. When we solve this down for the force, we get a force value of 10.73 newtons upward, because again we get a positive value there. So then what the bubble wrap did was the bubble wrap made the time period last a little bit longer, and in making the time period to stop the package a little bit longer, it required a little bit less force to change the motion, as opposed to being in an ordinary envelope where the change in momentum was the same, but the time period was shorter, and so the force was greater. Ponder physics.